or something. There we go.
It's not a really big deal because I don't think he watches them.
Yeah, I don't think he does either.
Because if you had to watch them, I went back and looked at all the groups. That's like 12 hours that he would have to sit there. I think he just says, okay, you submitted the link. He goes and pushes the link to see that there's actually a video, and then he stops.
Just to teach you, if you do watch this, we've actually been here for about 30 minutes.
Yeah, we've been working hard.
We need to start over, guys.
Okay, so extending problem number 2. The following problem guides you through answering the question. Find an equivalent algebraic expression for sine tangent to x. Discuss each part and make sure you understand the process and can answer the question in your book. You will find a different process, but we introduce you to how this type of problem is answered in calculus.
I know, that sucks. But if you do the homework, lesson 1 teaches you how to find the stupid equations. Like I'm trying to find one where I have to write the equivalent equation. Yeah, I guess I had one that I did that. So it's kind of like this. They'll give you an equation like that, like the secant or a tangent. I guess I could just do that problem, but we could do it that one. It's not that bad.
Would they?
Because pretty much is what it's saying, if I remember correctly. Okay, so we have sine of. Can you see this, Jordan?
Yeah.
Okay. Of the -1, right, of the inverse of x. Okay, so pretty much what it's saying is x equals, I'm doing it right. All right, x equals this. That's what it's saying to us. So if we do it the way that this problem showed me how to do, because we're trying to get it in terms of, well, I don't know, this one doesn't tell us to do it in terms of sine and cosine. Okay, because I'll show you the example, and then maybe David will be able to tell us. Okay, so here we go. So the one I did was secant of inverse or arc tangent x, like that, okay?
Okay.
So all I know, we know x equals that. So what we do is, if I remember correctly, you go to this, the formula that, like, you go to the Pythagorean identity.
Okay.
And so what you end up doing is, right, you end up throwing in here, but instead of putting tangent, yeah, you end up putting tangent squared, yeah. So it goes like 1, gosh, this pen is terrible. Is there a black one? We go 1 plus tangent squared x equals c squared. What is this? You can just throw this guy. What's that? Okay, so then we would just plug in the value for it. And because we see x equals this, and we know this is squared for that identity, we plug in 1 plus x squared equals secant squared, right? And then so to get the value, we would go like that, square root it, and the square root of 1 plus x squared equals, that's our answer. That is an equivalent equation to this. And so that's why I'm looking at sine. And if we put sine in, if we did the Pythagorean of sine, we couldn't do it because that has to do with cosine. We have tangent. That's how you have to solve the stupid problem on homework. So we're trying to find an equation that's
So then to start off, you just said
X equals arc tangent, right? Or tangent, yeah, that's what X is saying.
Okay.
It said X equals this. Yeah, C, but that's what secant is, right? Is just saying, that's what I'm looking at. We don't have a one of that.
Okay.
Because tangent, I guess we might throw it, because tangent's right, is sine over cosine. We could do that. We could put sine over cosine, because then we could get rid of it and make it.
We can try it.
Over sine, which is cotangent, isn't it?
Yeah. Okay.
So I think that makes more sense. So if we had sine, which one is for cotangent?
Got this guy. This cosecant. Yeah, cosecant and sine.
Or just
All right.
reciprocals.
Yeah.
So that would make sense. So then I'm going 1,
Sorry.
I get 1 plus cotangent squared equals co squared, right? And then if we put the value in, because we're saying like x squared is really what we're, because x equals tangent, right? So what we're really trying to say is this guy squared would be x. I'm just trying to solve it that way. So I think this is the equation, like the theory, the identity we need. Now we just have to simplify it.
Gotcha.
So if you do it the way the homework teaches you, you'd go like this: put x squared in equals that. Square root each side. Square root of 1 plus x squared equals.
That makes sense.
That's what you'd get as an equivalent equation. Because really x squared is just saying tangent squared.
But then we have to take 1 over this to get sine.
Yeah, so I think that.
Like that.
Yeah, exactly. I think they're right. Yep. Because that's essentially what you're saying. That is squared. It's sine because reciprocal is sine. Oh, yes, that's it. Okay. Jordan, that makes sense?
Yeah.
Did you follow?
So the first step, you guys said x equals 1 sine over cosine, which is tangent, right?
So what we do is, okay, so we're trying to solve, like find an equation like with x that's equal to this equation, but pretty much like just taking the opposite identities of it. So we say x, to start off, x equals tangent, the inverse tangent, okay? So we know x equals that. So now we know, because we have tangent, we know we have to use an identity in trig that would give us, that we can like use to like manipulate our equation. And so we know tangent really is, all tangent is, right, is cotangent. Oh yeah, see, this is where tangent, the inverse tangent is 1 over cotangent. So that's all. If we would have done that, we would have got the answer. We just didn't put that in, whatever.
Okay.
But yeah, so okay, so we know tangent, the reciprocal of tangent, right? Because tangent is sine over cosine. So
Yeah.
it's asking for like the opposite of that, right? So we know cosine over sine equals cotangent. So what we do is we put in, so we have to find an identity that uses cotangent in it. And the identity is 1 plus cotangent squared
Okay.
equals cosine squared x, okay? So we know that, but this is asking for that. So it's really, when we solve it, how like we were doing it over here, because like we want to get rid of the square, the power, right? So we do that, we square root it, but then to get sine, to equal sine, we have to put 1 over cosine at the end. that make sense?
Yeah.
So that's all it is. Like this, these problems aren't hard. They're just tricky because you have to just know the identities and what the reciprocals are and what each thing represents. That's pretty much it.
Awesome.
Okay. All right, let's move on to the next part. Okay, so in your book, you'll find different process. Don't use the other process. Given that x is a side length, the output of 10 is an angle.
Mm-hmm.
Because the inverse, like we were just talking about,
Mhm.
flip them. So if the input is a side length, the output is an angle.
The angle.
Yep.
We begin by drawing the right triangle and labeling each part. How do we do that?
What?
So we do.
How do we do that?
What are the sides that we have so far?
We don't. Well, we would put that is one of our side lengths. And that is the other side length.
Okay.
Then it says find the third side length.
And I'll find sine of theta. Sine of theta equals.
Okay, let's see. Yeah, see, we got it right because we're end up looking for sine, which is what we did. Cool. Okay. Yep. See, look at see. Okay, so I'm looking at his. That's one of our sides. The unknown squared is the other side, or c squared. So c squared equals that, which is what we thought. On the third side, I don't know. Okay. Okay, so this is what it's saying, right? So we draw the right triangle. Okay. We know one of the sides is that. Because that's the opposite we got, right?
Mhm.
And one of the other sides is that was this equation. Was that? I don't know exactly which side or whatever, right? Okay, so what we're doing is this guy is going to equal the unknown side squared. Okay, but we'll take this off because there, we do that. And then all we do, let's just say he equals, because the unknown side we always do is C, because we have this side, that side, this side has to be, so we'll have to put C. Okay, and so then we just solve like how we normally would, so it's square root to get the power, square root to get the power, and we get the square root of 1 plus x squared equals C. Okay, so then we take that guy, we find that side, find the third side, which I don't know, and he doesn't show that too, so I'm gonna forget it. But now he says you can find sine theta. So you click on, yeah, because you're looking at the answer sheet too.
Yeah. Sine of theta equals.
So that's the equation we got. We didn't have it over x. So we're pretty dang close. Because all it was this problem was that. What answer we got? Over x. So I don't know how we got that, but I know how we got this.
Well, it's a little bit different because he has x cubed.
Oh, is that x cubed?
Yeah, it's 2 plus 1. Yeah.
It's like everything's to the power, right?
But then wouldn't you just divide, so you subtract this, so you get the square root of x squared would be the answer?
That's what I would think. Because if you divide that, you'd still get, yeah, x. Yeah, I'm thinking this is it. That's the third side.
I don't know exactly how we did that though. I don't know how we got this.
That's the same, because I know how we got this. I don't know where the heck this other x is coming from. Maybe from that? Okay, it's because this is saying this, right? Because we got this, then we get the opposite to find the problem, and this we're trying. That's what it equals, right? Remember, because we got 1 over cosecant, which is sine. And so I'm thinking because if we could sine of this, and then we're saying that is an x, so it gives us another x. I think. Because then if we solve for it. Because essentially what we're saying is 1 plus equals that, right? That's the only thing that makes sense to me, written algebraically. That's all my God. You have any ideas, Jordan?
No, I have no idea.
That's the only thing that's throwing me off is just the x. And where we got the x from.
Yeah.
And needless to say, you don't have any problems like this in your homework. So.
I don't know.
I don't know either. I have no idea with that one. But I know how to do the other ones, so. Okay. We'll do number 3. Maybe we'll connect this one if we have time later. Okay, so number 3, it's pretty fun, right? Pretty easy. Sine, right? Is it x? Yeah. Minus cosine. Right, so we just have to factor it. So if we factor it, we should get right, because if we factor out the could be like really, because if you're trying to like, okay, well the factor or whatever, we have both of them. We could do pull out all of it really. So because if we times these, don't we get that?
I don't think so. No. Because
Would it just be we would get sine squared, wouldn't we?
yeah, we'd have to have
Minus, because this is what I'm guessing he didn't put this point out in front of it. Pretty much that's what it's saying. Yeah.
then factor.
Yeah, just factor it.
Oh, that's all we have to do?
Yeah,
Well,
just
then
factor.
yours is right then.
Yeah,
I mean, it's just this, but then just
yeah, that's all it is, right?
Yeah.
So you just take it, factor it how it was, and you should go. That's what he gave us. Because I'm pretty sure I went through and did my factoring crap. Where's my factor?
Sine x plus cosine. Sine times sine squared. I don't even know if this is the right answer though. You got
Yeah, so we take sine times sine times the cosine.
it'll have to be like sine squared plus cosine squared.
Cosine, no, it isn't that way.
That would work because sine times sine squared times sine squared would be
Sine. Yeah, and then cosine squared times cosine squared, negative cosine squared gives you cosine. That's all I thought. I think that he just left this off. Yeah, because when I was looking at, like, when I did my factoring, this is what I got. So like, okay, you're gonna factor. We have four, so we're gonna factor out like cosine squared, right? And that on this side, we'll add cosine and sine. So that would leave us this over there. That would be factored.
Yeah.
You can't factor it out. What did he do? He just forgot the hours.
Does that make
Okay.
sense?
Does that make sense, Jordan?
Yeah, that one makes sense.
Okay, good. The next one's a little harder, but not really. Not too bad. David will hit it for us.
Could you read it to me?
Yeah, cosine alpha tangent alpha minus 2 cosine alpha minus 3. 2 cosine alpha, yeah, minus 3 tangent alpha.
Look how.
Okay, so
Factor it.
yeah, we gotta factor it. So for me, when I was doing the homework and stuff, I found. So we'll take out.
So then this cancels out. One of these cancels out. So cosine alpha sine alpha minus 2. Is this kind of what you're doing, or am I completely off?
No, but you could simplify it if you wanted to, and just take one tangent and do that out of it. And then, so what I would do is factor out a tangent and
Okay.
then do that.
Okay. So
So you would have the whole thing you're doing, yeah, just tangent, alpha, yeah. Yep. No, you're right. Okay, that's this problem that you have right here is exactly right. Now you just factor this. So remember in Math 110, how we would take when we had a problem like this, we would find two numbers that add up to this, like the times to add to get to this, but add up to that.
but with this one, this would be multiplying tangent times this, and this.
Yeah.
When tangent multiplied times that, the tangent isn't multiplied times this.
I'm just telling you. I don't know. I just like all I know is like when doing the homework, I would just find look, because like I looked at this problem first and thought, okay, I could take out a cosine if I wanted to, right? That would be cosine and tangents.
Yeah.
But I don't know what it is. For some reason, I don't know if it's like a property of trigonometry or whatever, but they almost like always, if there's a sine or a cosine here, they almost always leave it.
Okay.
And they take out like whatever was there. And so we take it out, we leave the 3, and then if you factor this guy, it goes to cosine minus 3 and cosine plus 1, right? Because 3, negative 3, so negative 3 times 1 is negative 3, right? And then 3 plus 1 is negative 2. And if we times cosine to cosine, we get cosine squared.
Okay.
But then, like exactly what you said, right? I don't get how we take the tangent. We don't ever times them like these guys in that equation. But that is the answer. Like under homework, this will be your answer. I'm telling you, I don't know if it's just like it took me a while yesterday to get it because like I had to do a couple problems a couple times because I would always do because I'm like, well, I have to take this times this times this. Does that give me that?
Uh-huh.
No,
Yeah,
it doesn't give me that. Like if I take that times that, and then times that, it does, right? And then so like if I do this whole thing out, I'll get everything but the tangents. And if I take the tangent times those numbers, then I get it.
Okay.
But I just don't. I'm telling you, I can't explain it. I just know how to get the answer.
Okay.
Does that make any sense, Jordan?
No, I don't get that one.
Okay, so there's gonna be like I'm just telling like on your homework tonight or whenever you do it, or there's like tons of factoring problems,
Okay.
and you'll get good at it. It's
Okay.
just like this one. Okay, perfect. Here's a perfect example. But cotangent squared b. Yep. Then secant b is part of it. Plus cotangent b secant b minus 20 secant b. That's like a sucky problem. Okay, so first thing we do is we factor out secant b. Okay, when we rewrite it, we got cotangent squared plus cotangent b, well b, they're all b, so minus 20. Okay, so here we go. This is where it sucks. We have to find what times adds up to 20. But then, I mean, times together adds to 20, but equals 1.
Um, 5 and 4.
Yep. Right? Perfect. So you got cotangent b plus 5 minus 4, and that's the answer. So it's essentially doing the same. This problem just looks a lot better than the problem he gave us. Because I feel like what you did, I think is right. Like if you went through and did it all,
Uh-huh.
you would get, like if we took out the signs, left cosines, I think we end up getting,
Mhm.
we would end up getting the same answer that we got
Yeah.
without the tangent in front of
Uh-huh.
it. See, because I mean that's like once you look at it like this sucks, but then once you really do it, it's not that hard.
Yeah. I feel you.
Does that make sense, Jordan?
Yeah, that makes more sense.
Okay. I know there's like tons of problems like that on your homework. Like the whole
Yeah.
second half of it is just all factoring. Here's a harder, I guess we could do a little bit of a harder one, but it's just, I mean, it's not harder, it's just different because we don't have to factor out two different things. 3 tangent squared y plus 14 tan y plus 15. This is just different than the other one you're gonna get.
Oh, this is basically just oh, this is the worst. It's got these numbers. This one here.
Exactly. So this is what I did. I don't know if it's like the correct way, but I did it and it worked. Just if you get the answer to that, just write. Just go.
Did you do? Yeah. What's it called?
I didn't do that way, but you can do it that way.
I don't know.
I just did this. I just took out like so. I just broke it into almost like into two
Yeah.
problems. Yep, that's it. That's it. It's 3 tan y plus 5, 3 tan
Yeah.
plus 3. That's it. It's not that hard. But like you look at that problem and you can't do it a normal way.
Yeah.
You can't just factor out the tangent and so you have to like figure out how to do it.
Yeah.
But once you get it, you break it into two problems, and it's like, oh, it's not bad.
Yeah.
That makes sense, Jordan?
Mhm. Kind of.
So like, this
I
is
think
how
I did the homework.
I just, you know, you're good. I just looked at it like this. I kind of didn't look at the 14. I kind of looked at this guy, and I said, okay, what times each other, like two numbers equals 15? 5 and 3. So I was like, okay, they equal that. This isn't the way. Like if you do it on your homework, like they'll show you exactly how to break it all down. I just did it my like easy way. I said, okay, 5 and 13, get it right. Well, I have to times 3 tangents squared. So I have to have 3 tangents in my problem. But what do I times it by to square it without changing my 3?
Just tangent.
It's tangent.
How do you get the 14?
Well, because when you start multiplying it all out, you'll end up getting it. But I just kind of said don't. I just like didn't even look at it and just did it the other way. You can't do that for every problem. For this one, you can. For other ones, you can't. But all right, cool. Then the other 2 problems on the extension one, the factorings they're not that bad. I would say the final one, the 2 tangent one, is a little bit confusing, kind of like the first one. But they're not that bad. See, because this way is exactly how, like because you have to take the reciprocal of sine, right? And that like cancels out one of them. And then you see with that.
Okay.
It'll take, like, because if you do the reciprocal of that, I mean, this of that, they cancel.
Mhm.
And then you just get 1 plus 1, because that would be a 1 there now, plus sine equals cosine squared. And that over each other is tangent.
Yeah. Makes sense.
All right.
Cool.
Okay. Well, Thursday we have a quiz. I will be studying all Wednesday, so
Cool. I'll study.
we should be good.
Study too.
It's really, so this one's not bad, it's not hard, it's just confusing with all the identities and keeping track,
Uh-huh.
how to use them, when to use them.
Yeah.
But yeah.
Feeling it.
Are you good, Jordan?
Cool, guys. Thank you.
All right, man, I'll see you.
Okay, see you Thursday.
Okay. That probably didn't make